Hey guys, today we're going to work on ordering real numbers. When ordering numbers, we need to take the numbers and change them to either like a whole number, an integer, or a decimal, and then place them in order from least to greatest or from greatest to least. Let's try one. The square root of 12, we need to change that into a decimal or a whole number of some sort. If we try to take the square root of 12, there's no integer times itself that would give us 12. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. So I'm not getting 12 when I go in order with the whole numbers. 12 is in between. 9 is a perfect square because of 3 times 3. And then the next one up would be 16 is a perfect square because of 4 times 4. So we'll approximate 12 to be about 3.5 since it's in between these two numbers. Okay, 4 does not need to change. We'll keep that number the same. 204%. Now when we change a percent to a decimal, there's an imaginary decimal after that 4. With that decimal, we need to move it over twice to the left. 1, 2. And so 204% is the same as 2.04. And then the last number does not need to change. It's already in the decimal format, 2.9. Now that we have them written as decimals, we just need to place them in order from least to greatest. So the lowest number would be 2.04. And then 2.9. And 3.5 and 4. Now let's rewrite these numbers how they originally looked. So 2.04 is 204%. 2.9 stayed the same. 3.5 would have been the square root of 12. And then 4 was the same. Let's try the next one. Now on this next one, we want to go from greatest to least, but first we need to change it to either an integer of some sort or a decimal number to be able to compare them. 3.2 we don't need to change, negative 3.2. It's already in decimal format. The square root of 9, and then there's a negative out in front. Well, I know that 3 times 3 is 9. So the square root of 9 is 3, but since there's a negative out in front, we're just going to keep the negative with the 3. Okay, now we have 8 over 3. So let's do first in, last out. So the 8 will go in with dividing, and the 3 will go out. 3 goes into 8 twice. 3 times 2 is 6. With 2 left over, let's add a decimal in our answer and in the division box, and then bring a 0 down. 3 goes into 26 times. 6 times 3 is 18. When I subtract, I have 2 left over, so I'm noticing this 2 is going to keep repeating, which means the 6 up top will keep repeating. So 2.6 repeating, and there's a negative sign in front of that fraction, so this is a negative number. Now, the negative square root of 25 over 5. We need to simplify the negative square root of 25 first. Well, we should know that the square root of 25 is 5, because 5 times 5 is 25. And then there's a negative sign, so I'm going to put a negative out in front. Over 5. Now, if we do the fraction means to divide, and if we do 5 divided by 5, that's going to equal 1 whole. However, there's a negative out in front, so a negative divided by a positive is going to stay negative. So we've converted these into decimals or integers, and so now we need to list them from greatest to least. Now, be careful, these are negatives, so we have to think of it backwards from how positives would be. Let's look at a number line for just a second. Here's 0, 1, 2, and then -1, -2. So if you notice for positives, they go in order 0, 1, 2, and as you count up, the numbers get larger and larger. Going down from 0, -1, -2, they go more and more negative, and so the farther you go down the number line, the smaller the number is. So -2 is actually less than -1. Positive 2 is greater than positive 1. So you have to be careful with how you think about negatives. So the greatest number, the largest number, the number closest to 0, in this case would be the -1. And then we're just going to start trying to go out farther from 0 as we list these numbers out. And so the next farthest from 0 would be -2.6 repeating. And then -3 and -3.2. Now let's rewrite these numbers to how they originally looked. So -1 was the square root of 25 with a negative sign over 5. -2.6 repeating was -8 over 3. -3 was the negative square root of 9, and then -3.2 did not change. Remember, when dealing with negatives, it's the opposite of how you would have thought a positive would have went. Now we're going to look at comparing numbers. Before we do, let's just take a moment to look at the pictures I have at the bottom. When comparing numbers, we're going to need to use less than, greater than, or equal to. Now, y'all all probably have heard of the alligator. The alligator eats the greater number. So if it's facing towards the left, that number would be greater than the other side. Or if it's facing towards the right, the left side is less than the right side, or equal to. We also kind of need to remember PEMDAS. Parentheses goes first when we're simplifying numbers. Exponent, multiply and divide go hand in hand, and add and subtract go hand in hand. Let's try this first one. So we want to simplify this left side to figure out what number this is really talking about. And so this is kind of where PEMDAS comes into play. Again, we want to start with the square root. So we would take the square root of 16. Well, 4 times 4 is 16. And so the square root of 16 I know is 4. There is a negative sign in front of that. And then over 2. We haven't simplified that yet. Well, 4 divided by 2, we're dividing now. 4 divided by 2 is 2. But there is a negative out in front. So now we need to take -2 and add 3. Integer rule. So the -2 and then +3, we could flip that around and think of it as subtraction. So this could be like 3 minus 2, which would equal 1. So this side on the left is 1 whole. Let's simplify this other side. Now for PEMDAS, there are no parentheses or exponents. I don't see any multiplication in this, but I do see a fraction, which means to divide. So we need to do 35 divided by 7 first. Well, 35 divided by 7 is 5. And let's rewrite what we have. So we have negative 5.5 plus 5. Well, negative 5.5 plus 5. The signs are different, negative and a positive. So really we need to subtract since the signs are different. So let's take 5.5 minus 5 is a whole number. So it does need to go underneath the other 5 with the decimals lined up, and then you can add a 0 afterwards. 5 minus 0 is 5, bring down the decimal, and then 5 minus 5 is 0. So we have 0.5. Now we got to think about which number is larger, 5 or 5.5. And 5.5 is larger than 5. 5.5 also has the negative sign, so our answer is going to be negative a half, negative 0.5. Now we're comparing, we're trying to figure out which number is greater than the other number. And the alligator wants to eat the greatest number. Positive 1 whole is greater than negative 1/2. Let's try the last problem. Now we need to convert 300% to a decimal. Remember how I mentioned there's an imaginary decimal after the last digit in a percent, so after that 0. And we move it over twice to the left. So when we do that, we end up with 3.00 or just 3. And then we need to subtract the 4 from it. 3 minus 4, well, 3 minus 3 is 0. So then 3 minus 4 should be negative 1. Let's try it out. Now I want to put the larger number on top, so I'm going to actually flip it around and have the 4 on top and then the 3 on bottom. 4 minus 3 is 1, and then the larger number is 4, and it did have the negative sign out in front of it, so our answer is negative 1. Okay, let's try this one. Now, a half, I would personally convert that to a decimal. Let's use mental math for this. Let's think of money. Half of $1 is 50 cents, and so we would write that as 0.5 or 0.50 minus 1.5. Now, again, the larger number needs to be on top, so I am going to put the 1.5 on top and then subtract 0.5. Well, 5 minus 5 is 0. Bring a decimal down. 1 minus 0 is 1. Now, the largest number is that 1.5. It is larger than 0.5. And it has a negative out in front of it, so our answer needs to stay negative. So this side is negative 1. Well, let's compare negative 1 and negative 1. They are equal to each other. Okay, that's just a quick review on how to find the square root of numbers. We practiced listing numbers in order from least to greatest or greatest to least. And then we compared using symbols like greater than or less than or equal to. Don't forget the little alligator. He helps you know which side should be greater than the other side. Remember, the alligator eats the greatest number. And then PEMDAS. When simplifying some of these expressions, we need to use order of operations. Thanks for watching.